So we're going to look at two different sets of functions this time. Again, still exponential functions, but now we're adding different transformations in. We'll look at set C to begin with. We'll graph out the base function y equals half to the x. We know that this should be a decreasing exponential function. It is. Now we'll start looking at the transformations. Graph 2 is 3 times 1 half to the x. We enter it like so. Original's there. Now, it's difficult to tell from the screenshot we have on the calculator, but that graph has actually been stretched. It's been stretched vertically by a factor of 3. Might be easier to see once we get the next one on. We have 3/4 times 1 half to the power of x. And if you're wondering why I needed the multiply sign with this one and not the last one, technically I didn't. But it's always better to put the sign in when it's not needed than to have to need the sign and not have it. So if those two, 3/4 to the power of x is in there. It's been stretched vertically by a factor of 3/4. We could also say it was compressed vertically. What I'm going to do now for 4 and 5, I'm actually going to eliminate those last two functions and do 4 and 5 individually. So we have -4 times 1 half to the x. 1 half to the x will redraw itself. And there's with the -4. So it also flips as well as stretches by a factor of 4. So then if we put on -1/3, this should also be flipped upside down. And it should also be compressed. So it should actually be in between the two graphs that we already have, which it is. If we go back and clear those out, we take a look at set D. D starts off with 2 to the x. We just dealt with that with set B. Increasing, goes through 0, 1, and 1, 2. If we add on 2 to the power of 3x, this is one of those places where brackets become important. The calculator thinks at this point that the x is not part of the exponent. We need to tell explicitly that the x is part of the exponent. So we'll do that again. There's the original 2 to the x. And there's 2 to the 3x. You may think that that's also a vertical stretch. It's not. And it's difficult to tell that it's not. It's a horizontal stretch or a compression, depending on how you want to look at it. If we go and we add our last one, 2 to the power of, and this one's also difficult. We can't just type in 1 over 3x, because then the calculator will think that the x is in the denominator. So I'm going to put that in a way that's more conducive to the calculator. I'm going to put it in as x over 3. It's exactly the same thing, except putting it this way in the calculator is a little bit easier for the calculator to deal with. So we have the two graphs that we started with. We can kind of see that one coming up. It's been stretched out horizontally as well. Again, like with set C, I'm going to eliminate 2 and 3. I'll put in graph 4, 2 to the -2x. We'll get the original 2 to the x first. And there's 2 to the -2x. So this has been flipped horizontally. As well, the shape isn't exactly the same. It's also been stretched because of the 2. If we add in the last graph, and again I have to put this in a way that's a little nicer for the calculator, put it in as negative 2x over 3. We have the two graphs that we started with. This one has also been flipped horizontally, and it's been stretched out as well. So taking a look at the general function, we have four transformations that we can apply: a, b, h, and k. C is the base of the function, so it's going to be whatever it is. A can do two things. It can do a vertical stretch as well as a vertical flip. B as well can do two things. It can do a horizontal stretch as well as a horizontal flip. H is a horizontal shift, and K gives us our vertical shift.